Okay, here we go. This lesson is called Graphing Polynomial Functions. We're going to do 4 examples today. And before we do those 4 examples, I'm just going to review some information from earlier in the unit. And I'm going to tell you the basic steps we're going to follow for these graphs. Okay? So here are the steps we're going to follow to sketch graphs of polynomial functions. Step 1 is determine the zeros and their multiplicity. Okay? Determine the zeros and their multiplicity. Step 2 is going to be to determine the y-intercept. That's what you get when you substitute 0 in for x. Okay. Step 3, what we're going to do is we're going to determine the end behavior. Because that's beneficial when we graph, to know the end behavior ahead of time. And in step 4, if necessary, to make a graph look nice, you're going to need to plot a few additional points. Okay, so like I mentioned before, the multiplicity of a 0 is very important when graphing polynomial functions. Okay, so hopefully you remember this from lesson 2. Any 0 with the multiplicity that's even, for example, 2, 4, 6, 8, will bounce off the x-axis and return the way it came. Okay, so for example, the 0, 3, okay, the 0 of 3 may have a multiplicity of 2 because look, it bounces off of it and it comes back. Okay, it definitely has an even multiplicity. I can't say for a fact that it's 2, but since it bounces right off, it definitely has an even multiplicity. Okay, a 0 with an odd multiplicity like 1, 3, 5, 7, and so on will cross the x-axis. Okay, if the multiplicity is like 3 or 5 or 7, then it usually lingers there. Okay, if it's 1, it just passes right through. So for example, the 0 of negative 2 may have a multiplicity of 1 because it goes right through it. Okay, keep that in mind when we move on to the graphs on the next page. Okay, here we go. I have 4 examples today. Example 1 says graph f of x equals x plus 3 times x minus 1 squared. This problem also says to state the zeros and their multiplicity, state the y-intercept, and state the end behavior. Okay. So let's start with the zeros and their multiplicity. Do that over here. So the problem says f of x equals x plus 3 times x minus 1 squared. Trying to solve for the zeros, so I'm going to replace f of x with 0. So you can think about it like this. So we have x plus 3 equals 0. Then we have x minus 1 equals 0. And since it's squared, it means we have it twice. That means I'm going to get x equals negative 3, x equals 1, and x equals 1. We've already done stuff like this early in the unit. Now we're just doing graphing. Okay, so the zeros are going to be negative 3, the multiplicity of 1, and then 1 with the multiplicity of 2, because it occurs twice. Let's graph that now before we forget. -3, and then 1. Okay, so I'm trying to follow the 4 steps I gave you on the first page. We just did step 1. Now let's do step 2. Let's determine the y-intercept. I spelled that wrong, didn't I? Yeah, let me fix that. Okay, so like I was saying, let's determine the y-intercept. Substitute 0 for x. I just fixed the spelling just now. Substitute 0 for x. I'll do that over here. So y-intercept. So we have f of x equals x plus 3 times x minus 1 squared. We're going to substitute 0 in for x, so we're going to have 0 plus 3 times 0 minus 1 squared. 0 plus 3 is 3. 0 minus 1 is -1. Order of operations, remember, so be careful. Exponents, next. Okay, -1 squared is 1. So it's 3 times 1, which equals 3. So the y-intercept is 0, 3. Let's plot that. So our graph is starting to take shape. Let's do the end behavior next, because remember, I'm trying to follow the 4 steps I gave you on the first page. We just did the zeros and the multiplicity, and we just did the y-intercept. Now let's determine the end behavior. Let me copy down the problem from above. X plus 3 times x minus 1 squared. So let's think about this for a minute. X minus 1 squared, let's do that out. X squared minus double these, multiply them and double them, so minus 2x plus 1. Okay, that's what you get when you do x minus 1 times x minus 1. We've done that shortcut a lot this year. If not, then you're going to have to distribute, okay? And now, when you multiply these together, think about what you're going to get. You're going to have x times x squared, which will give you x cubed. Okay? I can keep going if I want, but I know that I'm not going to have another cubed term. So I know this is going to be my leading term, okay? Because if you think about it, I'm going to have minus 2x squared, then I have plus x, they'll have plus 3x squared. There's not going to be any other cubic terms or anything bigger than that. So I don't care what comes next. I know that it's going to be a odd degree with a positive leading coefficient. So here's my end behavior. Okay, because we have odd degree x cubed, odd degree, positive leading coefficient. So that's my end behavior. Because remember, that basic shape is going to be the one that looks like that. Okay. Let me get rid of that because I don't want that to stay there. Okay, so far so good. Now we just have to, let's plot a few additional points to make our graph look nice. So I'm going to I'll pick x equals -1. Let's do an additional point. Let's do x equals -1. I'm going to do 2 additional points. Let's do x equals -1 first. So I'll replace the x with -1. -1 plus 3 is 2. -1 minus 1 is -2. Order of operations, -2 squared is 4, and 2 times 4 equals 8. That means we have the additional point, -1 comma 8. Let's plot that. Now let's do an additional point of x equals 2. Let's do one more. Let's do x equals 2. To make our graph look nice, I'm going to do x equals 2. I'll just recopy the problem again. Two plus 3 times 2 minus 1 squared. That's going to be 5 times 1 squared. Again, be careful. This is not 5 squared is 25. This is 1 squared is 1, and then times 5. That'll give you 5. Which means if we have the additional point 2 comma 5. So let's plot that. Now remember, everything that we already did should come into play now, okay? We know what the end behavior is, okay? Let's go back to, well, let me connect these first. Something like this. Remember, this 0 had an even multiplicity. 1 with the multiplicity of 2. Even multiplicity means it's going to bounce off it like that, okay? Now we know what the end behavior is, so this graph is going to keep going up this way, and this graph is probably going to go down this way. I'm going to leave it like that. I would say that's good enough. Okay. Example 2 is similar to example 1, and then examples 3 and 4 will be a little different. Okay, so let's move on to example 2. Start with the 0 as a multiplicity. So here's our problem. So replace the f of x with 0, and let's get to work. X minus 5 equals 0. And think of x minus 8 equals 0, and then do it again. X equals 5, x equals 8, x equals 8. So my zeros will be 5, and then 8. And let's state the multiplicity of each because it's said to in the directions. 5 with the multiplicity of 1. And 8 with the multiplicity of 2. Let's graph those before we forget. And keep in mind, this is going to pass right through 5 because it has a multiplicity of 1. The 8 is going to bounce off of it because it has an even multiplicity, remember. Moving on, next thing we're going to do is we're going to determine the y-intercept. Do that down here. I'll copy down the problem. And you're just going to substitute 0 in for x and then simplify. So 0 minus 5 times 0 minus 8 squared. This might not always fit on the graph, though. Keep that in mind. I believe this one's not going to fit on the graph because 0 minus 5 is negative 5. And then negative 8 squared. Negative 8 squared is 64, so it's negative 5 times 64 is negative 320. So that's our y-intercept, 0, negative 320. I don't think I can fit that in my graph above, as long as I make each line 1. Write that a little neater, hold on. Okay, so just for consistency, I'll write it like that, just like number 1. Okay, 0, negative 320 is the y-intercept. Now let's do the end behavior. I'm just going to recopy down the problem again, just like we did before. F of x equals x minus 5 times x minus 8 squared. Let's do x minus 8 squared first. Now, you should know the shortcut by now to squaring a binomial. Square the first term, x squared, minus, multiply these together, 8 times the x and double it. So minus 16x. And then plus 64. And then just like number 1, when I multiply these together, x times x squared is x cubed. There's not going to be any other terms that are bigger than that. So I'm just going to leave it like that. It's a positive leading coefficient with an odd degree. So think back to lessons 3 and 4 for that end behavior. And it's going to be the following. As x approaches negative infinity, f of x approaches negative infinity. As x approaches positive infinity, f of x approaches positive infinity. Think about that. It's going to help us when we graph it. Okay, so what I'm going to do now is I'm going to get a few more extra points because we don't have that many yet. We only have 2 points. I'm going to try to get 3 more. Let's do x equals 6. Let's start with x equals 6. So 6 minus 5 times 6 minus 8 squared. 6 minus 5 is 1 times negative 2 squared. Exponents next. Negative 2 squared is 4, so 1 times 4 equals 4. So that means we have the additional point, 6 comma 4. Plot that. Let's go with, let's do x equals 7. Let's also get that additional point. Do that right here. So substituting 7 in for x in the original problem, 7 minus 5 times 7 minus 8 squared. So we're going to have 2 times negative 1 squared. Negative 1 squared is 1 times 2 is 2. That gives us the 0.72. Plot that. Right there. Now, I'm going to do one more. I'm going to go with x equals 9. Let's do x equals 9, and then we'll stop this problem. Let's do x equals 9 and see what we get. So substituting 9 in for x in the original problem. 4 times 1 squared. It's 4 times 1, which is 4. So 9, 4 is an additional point. At this point, I would say we're good to go because we know what the end behavior is and we know what the multiplicity is. So this is going to look like this. It's going to bounce off here, remember, because that's has an even multiplicity. You know the end behavior is going to be going that way. And this is going to be going this way. Also, keep in mind, since the degree was 3, there's a maximum of 2 turning points. So this cannot turn anymore, okay? That's the key point. Okay. 2 more. Example 3. This one is in standard form, okay? It's not factored form this time. Sometimes that makes it easier, sometimes it makes it harder, okay? It's going to be harder to get the zeros in the multiplicity. But let's get to work. Let me just copy down the problem. We're going to find the zeros. Take out the GCF, which will be x squared. And what I'm going to choose to do is I'm going to choose to take out a negative x squared, so the first term will be positive. Okay? I'm going to take out a GCF of negative x squared, which leaves me with the following. X squared minus x minus 2. Now I'm going to factor what's in the parentheses. What 2 numbers multiply to negative 2 and add to negative 1? It's going to be x minus 2 times x plus 1. Because negative 2 times 1 is negative 2. And negative 2 plus 1 equals negative 1. The other thing I want you to think about is this negative sign up front can be thought of as negative 1 times x squared, or times x times x minus 2 times x plus 1. Now let's do our zeros. You can ignore negative 1 equals 0. You have x equals 0, x equals 0, x minus 2 equals 0, and then x plus 1 equals 0. X equals 2, and x equals negative 1. Okay, so here are my zeros. We got negative 1, 0, and 2. Negative 1 has a multiplicity of 1. Zero has a multiplicity of 2 because it occurs twice. And then 2 has a multiplicity of 1. At this point, we should probably graph that before we forget. So negative 1, 0, and 2. Those are going to be the zeros or the x-intercepts or the roots. Negative 1, 0, 2. Let's do the y-intercept next. You might know the answer already, but replace the x with 0. So negative 0 to the fourth power plus 0 cubed plus 2 times 0 squared. That's going to be 0 plus 0 plus 0, which equals 0. So that means the y-intercept equals 0, 0. The reason why I said you might already know that is because we already graphed that. So you really don't have to do all that work out. But that's why it's 0, 0. Now let's do the end behavior. Now this end behavior should be easy because it's already in standard form. Right? As opposed to number 1 and number 2 where it was not in standard form. Negative leading coefficient with an even degree, the end behavior looks like that. Okay, remember that goes back to lesson 3 and lesson 4. So it's approaching negative infinity in each direction. Approaching negative infinity. And approaching negative infinity. Now let's get a few additional points. Probably gonna go with, I'll go with 3 more. Let's do x equals 1. Okay, so in the original problem, I'm not going to recopy it because this problem's already long enough as it is. It's negative x squared, so negative 1 means the fourth power, plus 1 to the third power, plus 2 times 1 squared. Now you have to be careful, okay? This is not negative 1 to the fourth power. This is 1 to the fourth power and then times negative 1, okay? So 1 to the fourth power is 1, and then with the negative out front becomes negative 1, and plus 1, and then plus 1 squared is 1 times 2 is 2. Order of operations is very important. So that gives you 2, which means the additional point is 1 comma 2. Let's graph that. Let's do another additional point. Let's do x equals 3. So I'm not going to recopy everything, but negative 3 to the fourth power plus 3 to the third power plus 2 times 3 squared. Now, even if this does not fit on the graph, it will be helpful to us, okay? So 3 to the fourth power is 81 times the negative out front is negative 81 plus 3 cubed is 27 plus, again, this is not 6 times 6 is 36. This is 3 squared is 9 times 2 equals 18. And when you add those, you get negative 54, which we're not going to be able to graph, but it's good to know that. So what I'm going to do now is I'm going to do one more additional point. I'm going to go with x equals negative 2. And let's see what we get. We have negative, going back to the original problem, which is also copied right here, by the way, negative 2 to the fourth power plus negative 2 to the third power plus 2 times negative 2 squared. Negative 2 to the fourth power means negative 2 times negative 2 times negative 2 times negative 2, which is 16 times a negative out front is negative 16. Negative 2 cubed is negative 8. Negative 2 squared is 4. And then 4 times 2 is 8. So this gives us negative 16, which is also not going to be able to be graphed, but it does help us out. Okay. Let me start sketching the graph. This is the final 0, so it's never going to come back up, so it's going to keep going down. And remember, 3, we have the point 3, negative 54, so it's going to go down very slowly. Now we know that this 0 has a multiplicity of 2, so it's going to bounce off it and then come back. And then we know it's going to go down very slowly because we have the point negative 2, negative 16. Now the only question is, how far up does this go? And it's not going to be very far, and I haven't gotten that point, but I'm just going to estimate it like that, and that's good enough. I know it bounces off and comes back up before it goes back down. Okay, let's move on. Let's do one more. So this is just a sketch, by the way. This is not absolutely perfect right there, but I'm just estimating it. Okay. Let's move on. Let's do the last one, example 4. Okay. Same process. Let's start by getting the zeros and the multiplicity. Again, we're just sketching these as best as we can. So f of x I get the zeros, so I'm going to do 0 equals x to the 4th minus 4x squared. Take out the GCF of x squared. This is the difference of two squareds. Remember, a squared minus b squared equals a plus b times a minus b. So if you want to think about it like this is x times x. This is going to be x plus 2 times x minus 2. I just rewrote x squared as x times x, and x squared minus 4 becomes x plus 2 times x minus 2 when you factor it. Okay. So we have x equals 0, x equals 0, x plus 2 equals 0, and x minus 2 equals 0. So x equals negative 2, x equals 2. So for my zeros, again, I like to go in order from smallest to biggest. Let's say negative 2, 0, and 2. And then state the multiplicity of each. Negative 2 multiplicity of 1. 0 multiplicity of 2 because it occurs twice. Keep that in mind. And then 2 with the multiplicity of 1. Plot those. Following the steps from the first page, the next step is going to be to determine the y-intercept. You might know the answer already. Okay. substitute 0 in for x. We have x to the fourth power minus 4 times 0 to the second power. So that's 0 minus 0 is 0. Now let's do the end behavior. It's a even degree, positive leading coefficient. So the end behavior is going to look like that. It's going towards infinity in each direction. Think back to lesson 3 and lesson 4. In both directions, f of x approaches infinity. Let's get some additional points now. I'll go a little fast because we've done a lot of these already. I'll start by doing, let's do x equals -1. You know what? Yeah, let's do x equals -1, why not? I'm not going to recopy the problem. I'm just do -1 in the fourth power minus 4 times -1 in the second power. -1 in the fourth power is 1. 1 minus 4, because -1 squared is 1, times 4 is 4. That's going to give us -3. So we have the additional point, -1, -3. Let's plot that. Let's also do the additional point of, let's do x equals +1. Let's try that one. Let x equal +1. Let's see what we get there. So 1 in the fourth power minus 4 times 1 in the second power. 1 in the fourth power is 1. It's going to be minus 1 squared is 1 times 4 is 4. So again, we're going to get -3. So the additional point, 1 -3. I'll do one more. Let's do x equals 3. See what we get when we do x equals 3. So it'll be 3 to the fourth power minus 4 times 3 squared. 3 to the fourth power is 81 minus 3 squared is 9, and 9 times 4 is 36. It's going to give us 45. So we're not going to be able to fit that, but we know the end behavior and we have enough. I'm just going to go and graph it now, sketch it. Even multiplicity, so it bounces off and comes back down. And we know the end behavior. That looks good enough to me. And again, these graphs aren't perfect. They're more sketches, but we know, but these are the basic steps, and you really should follow them when you're graphing polynomial functions. But again, our graphs are not perfect if we had to estimate in number 3, for example. But those are the basics to graphing polynomial functions. If you watch the entire video, then shout out to you.